Hello everyone, my name is Dharmesh Kumar Kishore Chandra Chakrala, and today we are going to see Standard 8 Science, Chapter 16. The name is Light. So we all know that God has given us five senses, right? And what are these five senses? Are sight, hearing, taste, touch, and smell. Now, what are these senses useful for? So we can say that everything we do is in one way or the other connected to our senses. For example, from our eyes, we can see the things around us, like we have tables in our homes, we have chairs in our homes, we can read, like we can see when we are on the road, on a bicycle or any vehicle. From hearing, we can hear the sounds, we can listen to the songs, we can listen to conversations. From taste, we can taste the food. From touch, we can touch and feel the surfaces, like you can touch a rose petal and feel the surface. From smell, we can smell different types of foods, different types of foul smells, good smells, right? So, to see the world, to feel the world around us, we need senses. That is the importance of senses. And from the senses, we are focusing here on sight. In this chapter, we are focusing on sight. Right? So, by means of sight, by means of our eyes, we can see the world around us. Right? But there is a question that imagine a situation where in daylight you can see everything clearly, like why? Because of sun. But when the sun sets and the night rises, can we see everything? Without light, let's say without a tube light or without a lamp, can you see what is there in your room? No. Why? Because there is no light which can enter our eyes. Right? So we can say that our eyes are enough to see? No, because there is a difference in seeing things in day and seeing things in night. So when there is day or when there is light after the sun has set, you can see that the light will get imparted on an object. Suppose this is an object lying in your room. Right? In daytime, there will be some light imparting on this object. In the light, some of that light will be absorbed by this object, depending on the property of the object, and some of it will get reflected. And if we are standing here, it will reach our eyes, and then we will be able to see the object. But in the night, we'll have to find artificial light or maybe the moonlight to see objects. So we can say that to view an object, we need light, right? So light is very important to see. As it is written in the book, that light from an object enters our eyes. Now, the objects are of two types, and the light entering our eyes will be of two types of objects. One which can emit the light, like the sun. The sun emits the light. Sun doesn't need any external support for its light. While the moon, we all know that the sun rays impart on moon surface, then it gets reflected and then we can see the moon on Earth. Right? So the light may be emitted by the object or reflected by it. Okay, the object can either emit light or the light gets reflected from its surface, and then you can see it when the light from the object enters your eyes. Now, the what we saw was that the light was getting reflected from the object, and then it was entering our eyes. And for that reflection, there are some rules. And these rules are called laws of reflection. Now, there are some activities in your book. One of the activities is that there's a mirror on a table and there is a comb. This is just a rough sketch of the comb. Now, what you're going to do is you are going to cover the comb in such a way that only the gap between two bristles is exposed to the light. Now, if there is a source of light from here, the light will be imparted on the comb, and by means of this gap, it will get reflected. Sorry, it will get imparted on this object. Let's see. Let's call it a mirror. So when gets imparted on the mirror, you can see that mirror will reflect the light, right? So a beam or a ray of light will get reflected from the mirror. Now, if you adjust the torch, like, instead of keeping the torch here, if you keep the torch here, and then if the light gets enters the comb, then the angle will be different, right? So depending upon the position of the torch, the angle of the rays getting reflected and imparted will be changing. So what we saw that this is the mirror, and the rays getting imparted on the mirror is called incident ray, and the rays getting reflected from the mirror is called reflected ray. Now keep one point in mind that several rays constitute one beam of light. Air in our own language, we are calling the beam of a light as ray. So this ray is a group of several rays. Okay, now there is an activity. What you're going to do is that first you are going to draw a line where which shows the mirror. The mirror is steady, it is not moving. Then we are going to draw a normal from the surface of mirror. This normal is, you can also call it as, it is drawn at a right angle. Right? Now, if the ray is getting inserted here and it is getting reflected over here, So this is called incident ray, and this is called reflected ray. So here, two angles are coming into the picture. This angle, it is called angle of incidence, and the angle from which the ray is getting reflected is called the angle of reflection. Right? We have, what we do, we have drawn a normal to the reflecting surface, which is the mirror. And from that mirror, we have received angle of incidence and angle of reflection. Now, depending upon the angle of incidence, the angle of reflection will change. For example, if we draw it like this, let's keep it a little wider. So here, you see that the angle of incidence is wide, is bigger as compared to this case. So the reflection angle will also change. So here there's a theory in our book that if we note down all these changes and the difference between the angle of incidence and angle of reflection, we will come to know that angle of incidence will be just as equal to angle of reflection. Right? The angle of incidence is always equal to the angle of reflection. So this is the relation between the two angles. What if light is thrown along the normal? So in this case, you have to imagine that this is your reflective surface and this is the normal. So if you throw light from this along this line along the normal, it will get reflected back to you, right? So in this case, if the light is thrown along the normal, the light will repeat its path back in the opposite direction. Right? So if this is if this is the incidence ray, then the same will be the reflected ray. There is another activity which shows the result that incident ray, normal, and reflected ray lie on the same plane. Right? Now, there's a phenomenon called lateral inversion. So what does this show? So there is a figure in your, activity in your textbook 16.2. What does it say? It has a figure which is your this is the reflective surface. Right? The P and Q. And there is a source of from O. Let's call this point O. And there are two ways getting incident on this surface. OA and OC. Now these rays get imparted, right? Like this. So we can see that the rays are not meeting here. Let's call it B, D. Let's make sure that the directions are correct. And here, if we extend these rays, Then they will meet at the point called I. Right? This is a figure which you have to consider for this case. So what we have seen here is that there is a source of light called O. Out of that source, there are two rays, OA and OC. And then draw the reflected rays like AB and CD. And do they meet? No, they do not meet here. So, if a viewer is here at the point E, the rays are not meeting, but rays will meet at point I, which is behind the surface of the mirror. So what we can see here is that the image is virtual. In reality, there is no image here, but what we are saying is virtual image, and it is formed by I. And you may recall that an image formed by a mirror is actually not like the actual object. We will see that the left of the object appear on the right hand side of the mirror, and the right side of the object appears on the left side. Like if you see yourself in the mirror, if you have sight in your hairstyle, if you have side parting on your left, you will see the side parting on the right hand side of the mirror. And this is called lateral inversion. Now there's a concept called regular and diffuse reflection. So there are two cases given in the book. Like for one, it is a irregular surface, and the rays imparted on this surface are parallel to each other. But since the surface itself is irregular, the reflected rays will be going half parallel. Right? They will be going in different directions. So in this case, the reflection is diffuse or irregular. It is not because of the failure of law of reflection. Okay, always remember that. It is because of the reflecting surface like this is irregular. And when surface is regular, if the rays that are imparted on rays are parallel to each other, you can see that the reflected rays will be not like this. It will be also in a particular direction. So what this gives is regular reflection. So it is totally dependent on the surface, the reflecting surface. Okay. Reflection from the smooth surface is called regular reflection. And images are formed by regular reflection. And there is another topic in here that reflected light can be reflected again. Like whenever we go to the saloon, there's a mirror in front of us, right? But not in that mirror, we can only see the front part of our head. We cannot see the rear part of our head. So when the barber is trying to show that he has cut hair uniformly or well from the back of your head, then what he does is that he gets another mirror out, and in that mirror you can see the back of your head in the mirror which is in front of you. Right? So same thing is on telescope. Like we have seen earlier that in submarines and tanks, there is a thing called periscope. There is something like this. And there's a mirror here, and there's a mirror here. So if suppose you are watching from this side, and the object is centered here. So the light from the object will be first incidented in this mirror, then from that it will go to this mirror, then it will reach your eyes. So we can say that the reflected light got reflected again, right? It first got reflected here, then got reflected from this surface, and then it reached our eyes. So these are the two examples of the reflected light getting reflected again. And there is a concept called multiple images. So if the mirrors are at angle, suppose these two mirrors are at a certain angle and there is a coin here. So what will you get? You get more than one reflection, right? In this case, we have used two mirrors in a combination. And if the mirrors are hinged here, like door is hinged to the wall, if we move the mirrors, the reflection will move as well. So how many images can you see here? Is the real question. And there is a case of kaleidoscope. Now, for kaleidoscope, you make a prism and you put it into a cylinder, right? And on cylinder, then if you see from one side, you can see different patterns. When you are watching the other side from the hole of kaleidoscope, you will see variety of patterns in the tube, right? And there is an interesting feature that the pattern you see in kaleidoscope will not get repeated if you see again. Right? So that is the use of kaleidoscope, which is done by designers of wallpapers, fabrics, and artists to get an idea of the new pattern. So that was the example of multiple images. So that's it from this lecture. I hope you liked it. And, if you liked it, please leave a feedback below. And thank you. I'll see you in the next lecture.